to my ankles. She claimed the streets up to my knees. She claimed the streets the town of Chicago. She claimed the rise is following me. It's about to break of day. She came and then she drove away. Sunlight in her hair. She claimed the streets are the river of sadness. She claimed the streets up to my thigh.
Okay, hi there. Today I'm going to be looking at Chapter 1-5, Solving Inequalities for Algebra 2. Alright, so I'm going to jump right in. First one is, what inequality represents the sentence 5 fewer than a number is at least 12? So before I do that, just a quick reminder, inequalities are greater than or less than. Okay, it could be, sometimes we put the or equal sign underneath it. Could be one of these. So those are the 4 signs we're working with. All right, so you need to remember, somehow keep it straight in your head. Usually kids have got this down, you know. But, you know, if I was to say that, you know, 6 is greater than 4, you have to remember a way that that sign stays true. Now, I'm part of the original video gaming generation, which means I grew up on Pac-Man. So, you know, I remembered that Pac-Man eats the bigger number. That's the way I did it. You have to find your own way to remember which way is bigger, okay? Anyway, back to this. So I got 5 fewer than a number is at least 12. So if I have 12 over here, 5 fewer than a number. This is the tricky part, because 5 fewer than means you don't go 5 minus the number. It's actually the number minus 5, because it's 5 fewer than. Think about it this way: if I had $5 fewer than you do, and you had 20 bucks, then I have 15. So you subtracted 5 from the 20, not 20 from the 5. All right, at least. So the n minus 5 has to be greater than the 12. And when it says at least, that implies it could be also equal to, you know. So I'm going to throw that line underneath it, which makes it or equal to. Not just greater than, but greater than or equal to. Okay? And that's the answer. That's it. That's all they were looking for. Number 2. All right, this one. The thing with inequalities is you really treat it like an equal sign. The one exception, and I'm going to put a star next to this, is if you multiply or divide both sides of the equation, I should say of the inequality, not of the equation, although it's really almost the same. The only thing is equation implies an equal sign. You must flip the sign. And let me give you a quick example. And it's very often the last step. You know, if I have negative 2x is greater than 4, and I, you know, divide by negative 2, I have to flip the sign when I do that. So I get x divided by negative 2. It's negative 2. But that sign gets flipped because I just divided both sides by a negative number. Okay, so that's what I mean by you know, flipping the sign. Just switch it the other direction. If there's a line underneath it saying or equal to, just leave it there. Okay, don't add the line or subtract the line. All right, so next, here I go. I'm going to start by subtracting 1 from both sides. 4 minus 1 is 3. Over here I got negative 3 times 2x minus 5. Okay, so there's 2 ways to go about this. You could either do the distributive property here. You could also divide the whole thing by negative 3. I think I'll do the distributive property just to get that out of the way. So negative 3 times 2x is negative 6x. 3 times 5 is 15. So the negative times the negative is positive. Okay, next I'm going to subtract 5 from both sides. Let's zoom in a little bit, need a little room. So now I got 6x is greater than or equal to 3 minus 5 is negative 2. Divide by 6, negative 6. Almost lost that negative, so I'm running out of space. So I got x is, now here's where I have to flip the sign, okay, because I just divided both sides by a negative number. So it goes this way, and I got negative 2 over negative 6. So negative 2 divided by negative 6 is positive, and 2 6 can be reduced into 1/3, and that is the answer. Okay. All right, so I just realized I made a mistake there. My mistake, and none of you guys caught me on that one, was over here, the 5, because 3 times 5 is not 5. 3 times 5 is 15, so I'm going to just quickly change this stuff here. So that should be plus 15. Then I'm going to subtract 15 from both sides. And when I do that, over here, I get 3 minus 15 is negative 12, which gives me a round whole answer. I'm still dividing by negative 6. Negative 12 divided by negative 6 is positive 2, so that's actually what the answer should have been. Sorry about that, but glad I could fix that. All right. Next one, it's a word problem. Rather lengthy one. I already wrote it down. Sorry for the length, but that was the way it's structured. All right, so the movie rental company offers 2 subscription plans. You can pay $36 a month for unlimited rentals, or you can pay $15 per month and rent each movie for $1.50. How many movies must you rent in a month for the first plan to cost less than the second plan? All right, so I'm going to write an algebraic expression for the 2 plans, and then I'll go from there, okay? Let's see. If I did the first plan, it's $36. And it's a flat plan, so that's it. It's just 36, okay? So there's not much to that one. The second one is a little trickier. It's $15 per month. And then you're going to pay $1.50 per rental. Now, so it's not just $1.50, it's $1.50 each time that you rent a movie, which means, if you rented 2 movies, that's $3. So you're multiplying the 1.5 over and over again by however many movies you rented. So these are my 2 expressions. Now, if I want to know, first one to cost less than the second one, if I have the first one over here, and I want that to cost less than the second one, then the inequality should go that way. Okay, so on the right side of the inequality goes the 15 plus 1.5n. All right, now I'm going to solve this. It was probably harder writing down all those words than it was actually solving this equation. I'm just going to subtract 15 from both sides, and 36 minus 15 is 21. And my last step here, remember there's multiplication implied between that 1.5 and the n, and the opposite of multiplying by 1.5 is dividing by 1.5. And when you punch that into your calculator, 21 divided by 1.5, you get 14. So that, oops, I shouldn't make that an equal sign. It should stay an inequality. So remember, if I was going to read that, that's saying n is greater than 14. If I was to switch this around the other way, it would be this. Either one of those is correct. When you switch which is on what side of the n being on which side of the inequality, you also have to switch the inequality. So make sure the n stays greater than the 14. Okay? All right. That was number 3. Next one, number 4. The next few have these all the same directions. Is the inequality always, sometimes, or never true? All right, so I'm on number 4, and I got this. Negative 2 times 3x plus 1 is greater than negative 6x plus 7. All right, so I'm going to solve it down, and then I'll talk more about whether the always, sometimes, or never, which one it is. Okay, so if I take this and do distributive property, negative 2 times 3x, that's negative 6x. Negative 2 times 1 is negative 2. Okay, next I'm going to add 6x to both sides. These cancel, those cancel. Ooh, something interesting is happening. I got negative 2 is greater than 7. So since all my variables cancel, this is either going to be always or never true. Now the question is what you're left with when everything canceled out, is it true or not? Is negative 2 greater than 7? No, it's not. And if you have troubles, you can always think of a number line. You know, here's negative 2, here's 7. Smaller numbers are on the left, greater numbers are on the right. So 7's on the right of negative 2, which means this is not true. It's false. It's never true. All right, so that's that one. Number 5. 2 times 2x minus 3 is less than or equal to 3x plus 8. All right, so next, same idea. I'm going to solve it out, see what happens. Distributive property first, parentheses by order of operations. 2 times 2x is 4x. 2 times 3 is 6. 3x plus 8. All right, I'm going to bring my x's to one side. If I subtract 3x from both sides, that would be a good start. Which leaves me with 3x from 4x is 1x, or just x, minus 6 is less than or equal to 8. Add 6 to both sides, and I get x is less than or equal to 14. So this one would be one of those sometimes true, because sometimes x could be less than 14. It could also be greater than. So unlike the one above, where all the variables canceled out, this one didn't. So I'm getting sometimes true for that one. Okay. Number 6, solve and graph the equation. Solve and graph the solution. Sorry, not the equation. I got 7 is less than 2x plus 1, and 3x is less than or equal to 18. All right, so this is really a compound one because there's 2 of them here. So I'm just going to draw a line in the middle, solve the 2 of them. We'll talk about graphing it. It's going to be a graph on a number line, not on a 4-quadrant graph. All right, so if I subtract 1 from both sides, over here I'll get the 2x alone. 7 minus 1 is 6. Next, I'm going to divide by 2. Opposite of multiplying by 2 is dividing by 2. And I get x is greater than 3. Okay, the right side is a one-stepper. Divide by 3. I get x is less than or equal to 6. Okay, now on my number line, I'm not going to make a big old fancy one. I'm just going over here. I'm going to put Here's 3, here's 6. I'll put 0 down there just for posterity's sake. All right, now if it's, and I'm going to write this down for you guys. If it's one of these two signs, it's going to be an open dot. If it's one of these two, if it's got the line underneath it, then it's a solid dot. Okay, which means as I look at this, you know, the x is greater than 3, that doesn't have a line underneath it, so that will be an open dot. I'm going to put an open dot over the 3. X is greater than or equal to, sorry, less than or equal to 6, does have the line under it, so that's going to be a solid dot. All right, now, x is greater than 3, that's going this direction, and x is less than 6, that's going this direction, which means the two lines are actually going to meet in the middle. So I'm just going to connect them, all right? The two arrows would have pointed at each other, which means they connect. So anything between those two answers, 3 and 6, and it could be 6, it can't be 3, but it could be 6, is a solution. And that's what it looks like on a number line, okay? If you got questions on that, please bring it to class. 7. Solve and graph the solution. All right, once again, it's another compound one. 7 plus k is greater than 6, or 8 plus k is less than 3. Okay, so once again, I'm going to draw a line down the middle and solve each one independently. Subtract 7 from both sides over here. I get k is greater than -1. On the right, I can subtract 8. These are nice and easy to solve. K is less than -5. Notice I didn't flip the sign there. It's only when you multiply or divide, not add or subtract, that you switch the arrow. Okay, so draw my number line here. All right, so here's -1, here's -5. Remember, negative numbers, like a number line, here's 0. So -5 is less than -1. All right, k is greater than -1. This one, since they both are just less than or just greater than, they're both going to be open dot. And let's see, k is less than -5, so that would be going this way. K is greater than -1, that would be going this way. So that's what my graph looks like when you graph the solution. All right, and that's that. All right, I got one more, number 8. Here's a real compound inequality. I got 6 is less than 2x plus 2 is less than 24. Okay, so I'm focusing on the middle. You know, I'm looking at that. You really want to try to get x alone, okay? I see students trying to work with the left side of the inequality, the 6, making that 0, start by subtracting 6. That's really not the way to do this. What you want to do is try to get this here x alone, which means you solve it like a regular equation, you know. The opposite of adding 2 is subtracting 2. Now what's different about this is this has 2 inequalities, so I'm going to subtract 2 from all 3 parts. When I do that, those cancel, so I'm left with a 2x in the middle. 6 minus 2 is 4. 24 minus 2 is 22. And next I want to get that x alone, which means the 2 and the x are connected by multiplication. There's always multiplication implied there, so I'm going to divide by 2. Once again, I'm going to divide all of this by 2. So I get 2 is less than, x is less than 11. And when I graph this on my number line, here's 2, here's 11. So they're both open dot because it's just less than or just greater than. Now you can read, you know, you can sit here and take it one piece at a time if you like. If I take that, x is greater than 2, that would be going this way. And then if I took grab too much. Suppose I move that one away. Now I got x is less than 11. All right, so once again, I got a compound inequality, and their arrows are pointing at each other. So what you're going to end up doing is connecting the lines, okay? So I'm going to connect these two, and that's what my solution looks like. All right, and that is all I got for now. All right, so have a great night, and close it out with a little bit more music.
She came in town and then she drove away. Sunlight in her hair.